Today we'll be discussing angles of rotation. This happens to be part of the discussion in lesson 13.2 from our text, and we're only going to look at examples 1 through 3 in this video. So we'll be drawing angles of rotation, identifying coterminal angles, and also discussing reference angles. So let's get started with a few definitions. An angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. The initial side of the angle is the ray on the x-axis, and the other ray is called the terminal side of the angle. So in case you didn't get it from the reading there, we're working in the coordinate plane, which usually has an x and y axis. I'm going to sketch that here. Apologies if this isn't completely perpendicular. And so we're in the coordinate plane here. You'll remember that the coordinate plane, the x and y axis, divide the plane into 4 quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what we're going to be doing is we're going to be drawing angles where the vertex is at the origin, just like it says in the paragraph there. One side of the angle, which we'll call the initial side, is going to be right along the positive x-axis. So this guy right here is the initial side that they mentioned. I-N-I-T. Oh, goodness. Got to work on my writing and spelling at the same time here. Let's go ahead and keep going now. This is the initial side. And then as we draw our angle, we're going to rotate at the vertex around the origin. And we'll either go clockwise or counterclockwise. We'll talk about that in a minute, but I'm just going to go counterclockwise for now. I rotate and I make an angle. And where that angle ends up, the other side here, this guy, is called the terminal side. That's where it ends. So we create this angle here, right? This is the angle. Let's just call it theta. We use the Greek letter theta quite often to name angles. We create this angle by starting on that blue ray. Remember, a ray is a geometric structure where you have a point at one end and then it takes off in a direction to infinity. So it's a line segment with an arrow at one end, essentially. And we rotate by holding the vertex fixed, and we spin around and make that angle. And where we stop is the terminal side. So this is called an angle of rotation. Now, what we just drew is a positive rotation. It's a positive rotation when you go counterclockwise. So I could take a guess that this angle right here, as we did the rotation, we actually went past 90 degrees. We went in the positive direction here, past 90, right? This is obviously a right angle here. If we just, so this is 90 if we're spinning in this direction. So this might be something like, tack on another 30 degrees. This might be something like 120. That's a 120 degree angle that we just drew there. Terminal side is the initial side is the blue side. We wrapped around approximately 120 degrees, and now we're at the terminal side. That's a positive rotation when you go counterclockwise. I better write that in. Counterclockwise. Now we can do a negative rotation as well. I'm going to kind of split the screen into 2 here. And let's draw another coordinate plane. Maybe I'll do a better job with this one. There's my y-axis. There's my x-axis. And remember that initial side always begins with the point at the vertex and a ray along the positive x-axis. So that's always where we're going to start. But if we do a clockwise rotation, so if we start moving in this direction, and then draw our terminal side. So if we're making the angle this way, right? Now this is theta. This is called a negative rotation. What we just drew here is a negative rotation. And we're actually going in the clockwise direction. Right? When you start turning down from that initial position, that's a negative rotation. So this angle here I've drawn, this might be something like negative 45 degrees. I went about halfway from the positive x-axis to the negative y-axis. The important piece here is that we've just made a negative angle. So on this side, when you rotate this direction, that's a positive angle. When you rotate clockwise like this one, it's a negative angle. So be careful when you're drawing these angles of rotation. You'll end up in the wrong position if you're supposed to draw positive and you rotate clockwise. You'll end up in the negative position. Similarly, if you're supposed to draw a negative and you rotate in a counterclockwise direction, you will end up with a positive angle instead of a negative angle. Okay, lots of talking during this slide, but let me just review real quick what we've done. We've talked about angles of rotation, which are built with the vertex at the origin. We start with a ray on the positive x-axis. I've drawn mine blue. We rotate to a given position, either in the clockwise or counterclockwise direction, depending on if our angle is negative or positive. And where we end up is called the terminal side, and that's the one I've drawn in red. Okay, let's try and see what kind of problems we're going to have to tackle with these. So typically what we do is we start out by just being asked to draw some angles of rotation. And so you're going to immediately get half of these problems correct, because no matter what you do, you're always going to start with a dot at the vertex, and you'll always start with an initial side drawn along the positive x-axis. So you're half right if you just do that. From there, there's a few things we need to figure out. First of all, we need to decide if we're going in the positive or negative direction. Since this is positive 235, I know that I'm rotating in this direction. So I want to head in this direction here, the positive direction, because my angle's positive. The second thing to figure out is how far do I have to rotate around this plane, right? We're essentially starting to draw a circle, but we have to decide where to stop drawing it. So here's a rule of thumb. We're starting at 0 degrees, right? And every time you make a quarter turn, you add 90 degrees on. So 0 in the right-hand edge, 90 at the top, 180 would be if you rotated halfway around, 270 would be all the way down here, and then if you made it all the way back, that would also be 360. Now, we're trying to go 235, and essentially we're just going to fake this thing as best we can. So we know we're going in the positive direction. We go way past 90. We're going to go past 180, and we're about 55 degrees past 180. So that's probably about right here. We don't want to make it to 270. We're only at 235. So we want to make it to there, and then wherever you stopped, that's where you're going to draw your terminal side. So this is my angle, and then just to make sure that I know which angle you're indicating, I'm going to ask you to draw the number right on the angle. So this angle actually sweeps bigger than 180 degrees. And that's okay. When we work with angles of rotation, there's no limit to how big the number can be. You just keep spinning around and around. Let me just draw on the side here real quick an example. You could, if you wanted, you could draw an 800 degree angle, which sounds crazy. But you just start here on the or the initial side, and every time you go around, that's 360 degrees. So we'll start cranking around, and I make it once around, that's 360. I need to go all the way around again, and I believe that's 720, and then I need another 80 degrees to get to 800, which would be about there, not quite 90. And so this would be an example of an 800 degree angle. Notice my 800 is positive, so I started rotating in this direction. Always, if it's a positive angle, you rotate counterclockwise. But the point is, with these angles of rotation, we're not trapped between 0 and 90 or 0 and 180. We can draw angles that in geometry don't make a lot of sense, at least in terms of polygons. Okay, so that's an example of being asked to simply sketch an angle of rotation of a particular degree. Remember, if you get a negative problem, you're going to rotate in the opposite direction. I just want to remind you of that. Another thing you might be asked is simply to figure out which quadrant this angle is going to end up in. So we don't need to draw it exactly, but we are going to need to at least figure out which quadrant we're in. So let me remind you where the quadrants are. Quadrant 1 is up here in the upper right. Quadrant 2, upper left. Quadrant 3, lower left. Quadrant 4, lower right. And we are asked to figure out which quadrant negative 765 is going to be in. Okay, so we're going to have to do a little math here. That's okay. Remember, it's negative, so I'm going to start in this direction. So if I make it all the way around once, that's negative 360. I don't want to go all the way around a second time, though, because that would be negative 720. That would be too far. But if I went around another 180 degrees, that would be negative 540. And then if I went another 90, that'd be negative 630. And then I just need 45 more degrees, so about right here, to draw that angle. And that means that I'm in quadrant 1, right? I'm in quadrant 1 when I end, so I would be writing down C for my answer for this problem. So it doesn't ask us to draw the angle, but the best way to figure out where you're going to be is just to start sketching it out. And essentially you're going to go by 360 as many times as you can, and then you can break it down to 180 or 90 until you end up where you are. Okay, so we've drawn the angles and we've also decided what quadrant they're going to be in. Let's see what else we can do with these angles of rotation. We're going to define coterminal angles, which are angles in standard position with the same terminal side. So let me show you what I mean by this. I think I drew on a previous slide an angle which I said was about 120 degrees. If we put a protractor on there, I might be wrong, but 120 was something like this. It's 90 plus 30. So it's about like this. And the terminal side ends up being right here. So that's a 120, right? Now, there are actually an infinite number of angles with that red line as their terminal side. So that's why we're going to call these coterminal. They share a terminal side. And we can find these angles by going either in the counterclockwise direction or the clockwise direction. Let me draw another angle that is coterminal with this 120, and I'll go in the same direction. I'm going to draw the angle 480. So if I start here and go all the way around once, I'm at 360, and then I go another 120 and stop right there. That's a terrible rotation. My apologies for that terrible spiral there. But I wanted to show you that this, oh goodness, man, I'm having a drawing nightmare here. I'm a one-take wonder though, so I'm not starting over. 480, that's a 360 plus a 120. The angle 480 is coterminal with this 120. Another way to get to that terminal side is simply to start in the opposite direction. If I start in the negative direction and go around this way and stop at the terminal side, I get a negative 240. So this green angle here is negative 240, 240 degrees. That looks like 248, sorry. Negative 240 degrees. So this green one is coterminal with the 120 as well. So let me just write these down for a minute. We're saying that 120 degrees is coterminal with 480 degrees, and that's coterminal with negative 240. Now there are many other angles that are also coterminal, but I just want to take a look at these. The bottom line is if you want to find coterminal angles, you could just do some simple arithmetic. If I want to find an angle coterminal with 120 degrees, I can either add or subtract 360. To find the 480, I just did 120 plus 360, and I got a 480. To find the negative 240, I did 120 minus the 360. And that's how I got negative 240. And I can simply do those on my calculator, right? So coterminal angles, they're just separated by 360 degrees in either direction. And if you wanted to, you could go around 7 times 360 and end up with another angle that's coterminal. Let's take a look at the problems you're going to have to do involving coterminal angles. For our first set of problems, we're simply going to ask you a yes or no question. Are these two angles coterminal? And so my recommendation is you just take the first angle and you either start adding or start subtracting 360. And you decide which one to do based on whether the second one is bigger or smaller. Since 735 is larger than 195, I'm going to start adding 360 and see if I hit 735. Now, you might have to add it more than once. So keep going until you either hit it or go past it. Okay, so 195 plus 360, that's going to be 550. So it's still well short of 235. So let's add 360 again. If we hit 735, then we know they're coterminal. If we go past it, we know they're not. So 550 plus 360, that's like 9. What is that? 910? Yep. All right. Sorry, I was pausing to think there. Now 910, we missed the 735. So the answer here is a big no. This is a letter B. These angles are not coterminal. All right. You could even do it this way too. You could take 735 and subtract. Keep subtracting. You could subtract 360. You could subtract 195 and see if you hit 360. There's a bunch of different ways to do this. Let me just do this. Let's do 735 minus 195. If we hit a multiple of 360, then we know they're coterminal. If we don't, then there isn't. So 5 minus 5 is 0. We're going to have to borrow. Here's our algorithm. 13 minus 9 is 4, and that is 540. 540 is not a multiple of 360, so this is also a no. If you were going to get like 360 or 720 or some multiple like that, then you could say yes. 540 is not a multiple of 360, so that's also a no. I like this method better because I just keep hitting plus 360, and then if I hit it, it's a yes. If I miss it, it's a no. And you can do that right on your calculator. Okay, let's see what else we can do with coterminal angles. You're also going to be asked to find a coterminal angle that fits in between 0 and 360, so within one rotation. And that's pretty easy to work on too. You take a look at the angle you're given, in our case 650. 650, as you know, is bigger than 360. So I'm just going to start subtracting until I get in between 0 and 360. So let's just go ahead and do that math. We're going to go 650 minus 360. That's the wrong pen. $650 minus 360 is, what was that, 290? And 290 is within 0 to 360. So the answer for a coterminal angle between 0 and 360 for the angle 650 is 290. Now, if I subtracted 360 and I still wasn't in this range, I just subtract 360 again. Similarly, if you're given a negative angle, let's say we were given negative 62, and we needed to find an angle in this range, we'd simply add 360 until we got inside that range. So that's going to be 298 for this angle, negative 62. So there's definitely quick and easy math for figuring this out. You're either going to add 360 until you're in there or subtract 360 until you're in there. Okay, remember the answer for this one is just the 290. Another common type of problem is for us to find a positive and negative coterminal angle for each given angle. We're going to take a look at just number 17 here. So I already have 14 as a positive angle, but I need to find another one. Okay, so I just need one positive and one negative. Once I get there, I'm done. Usually, you do that by simply adding 360. In this case, you'll see that we get 374. And that is a positive number, and so we fulfilled that part of the problem. We also need a negative angle that is coterminal. So for that one, I'm going to minus 360. And when you do negative 14 minus 360, you get, that's going to be negative 346. And that is the other angle. So we were asked to find a positive and a negative, right? The positive angle is 374. The negative one is 346. Negative 346. These aren't the only two answers. You could add 720 and still get a coterminal angle that's positive, that's coterminal to 14, and so on. You could add multiples of 360, but I typically just start with 360, and as long as I get what I need, I'm done. It's possible that you could subtract 360 and still not get a negative number, then you just subtract it again, right? Like if your angle was 400 degrees, you'd subtract 360 once. That would get you to 40 degrees. Then you'd have to subtract 360 again to get a negative value. But the strategy is simply either add 360 or subtract 360, maybe multiple times, and you'll get one of each. All right. Let's talk about reference angles. For an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So there's lots going on in this definition, and I want to just be careful and make sure we're keeping track of things. The reference angle is a positive acute angle. From geometry class, you'll remember that acute angles are between 0 and 90 degrees. All right? So our angles are going to be acute, meaning from 0 to 90. Right? If we make it to 90, that's a right angle. So we want to be less than 90. And our angle, our reference angle, is formed by the terminal side and the x-axis. So basically, wherever that terminal side ends up, we want to fold straight down to the x-axis and figure out what that angle is. And you can see that clearly in this picture here. When you draw the angle, theta is the blue part, right? That's your typical angle of rotation. The reference angle is the fastest way back to the x-axis from that terminal side. So that's this one here. All right, this angle right here is the reference angle. And our job is going to be simply to figure out what the degrees of the reference angle is, at least in the next exercises that we're going to work on. So the problems are quite simply stated. Find the reference angle. And so you can see here that we have an angle that's 130 degrees. And what we need to figure out is what this angle right here is. Right? So what's this angle? What does it take to get from where we are back to the x-axis in the quickest way? Okay? So remember earlier when we were talking about these rotations, 0 started here on the initial side, and if we made it this far, it was 90 degrees. If we made it this far, it was 180 degrees. If we made it this far, it was 270, and so on, all the way back to 360. These are all degrees. Our angle made it to 130, and so all we have to do is figure out what's left to get to 180. So a little simple arithmetic is going to help us do that. 180 minus 130 is 50 degrees. And that's going to be the answer for our reference angle. Our reference angle in this problem is 50 degrees, this guy right here. Now, I want to warn you, it's not always that simple. And you think your way through things. Let me just show you another quick example down here in the corner. What if the original angle was something like 210 degrees? So here's my initial side. I rotate in the positive direction, and I end up right here with that terminal side at what we'll call 210. Now remember, your reference angle is the angle between the terminal side, and I'm going to make this thing red, and the x-axis. This time, the fastest way back to the x-axis is to go backwards. So the reference angle is this guy here. Do not do this angle back to the x-axis that way. We're not finishing off the rotation. We're simply drawing the angle and then figuring out the fastest way back to the x-axis. And the reason we do that is it has to be acute. If I were to draw this as the reference angle, that thing's obtuse. Okay, so we said we're at 210. Remember, this was 180. We went past 180. How far past did we go? Well, this time, instead of doing 180 minus 210, I'm going to do 210 minus 180 because 210 is bigger. So I do 210 minus 180, and that works out to be 30 degrees. So in this other problem here that I just made up, the reference angle for 210 degrees is just 30 degrees. For today's exercises, we're simply going to be identifying the reference angle. But if you continue with this lesson later, we're going to start applying trigonometry to these angles of rotation, and that's where the reference angles come in handy. So stay tuned for that. In the meantime, good luck with these exercises. You've got plenty to do, and if you need anything, you know where to find me. Take care.